Our first example is the power rule in a general expression. So if I have x to any power, what I'm going to do to find its antiderivative is I'm going to add 1 to the power, which is the reverse of finding the derivative, and then divide by that entire power. So when I find the general antiderivative, I get x to the n plus 1 divided by n plus 1 plus c. So when you see in example 2, when I have x raised to the third power and I need to find the general antiderivative, I add 1 to the exponent and divide by the new exponent. X to the fourth power divided by 4 plus c. That's my general antiderivative. Example 3. With a trig function, I just have to remember back to what gave us a derivative of negative cosine of x. So when I'm finding my antiderivative of negative cosine of x, my original function would have had to have been negative sine of x, because the derivative of sine of x gives me cosine, so the derivative of negative sine would give me negative cosine. Again, I want to include my plus whatever constant could have been there before we took the derivative, and that constant went to a derivative of 0. For my fourth example, I have a polynomial function. So when I have more than one power function, I just do each individually. So my general antiderivative is adding 1 onto my exponent of 3, which gives me x to the fourth power. So I have 2x to the fourth power divided by 4 plus x cubed divided by 3 minus 3x squared divided by 2, and I add on the x to the 5 that would have disappeared when I took the derivative, not forgetting whatever constant might have been there from the beginning. So I simplify this and I end up with 1/2 x to the fourth power plus 1/3 x cubed minus 3/2 x squared plus 5x plus c as my general antiderivative.